Good afternoon, good morning, dear friends. Myself, S.S. Sonigra. Today, I am going to discuss about the development of solid surfaces, namely prism, pyramid, cylinder, and cone. Dear friends, it's a very interesting topic. It's a very interesting chapter. Once you've gone through the basic concepts, you will be able to solve any problem related to the development of any solid. The solid may be regular shape, may not be, or it may be cut section, or it may not be cut section. Now, why we today discuss this chapter? Because many objects are there which are very difficult to manufacture by machining operations. For example, any liquid container or any hollow shape. So to fabricate those shapes or those objects, there is a need to use the basic concept of development. So in today's session, first we do revision of our earlier discussion. Some recap will be there. Then after we discuss some basic concepts, very basic problems, which includes some fundamental aspects. And then after gradually we will proceed further with some complicated problem with some complex situations. But everywhere one thing will remain similar, that is the basic concepts. Every time just very common sense as well as some basic things needs to be used when we solve any problem. So we start with the development. First we do revision. What is the development of solid? Assume a hollow object made up of a thin sheet. For example, this is a thin sheet. Clear? This is a thin sheet. We made a hollow object from this sheet like this. So we know this is what? It's a cylinder. Now if I cut this cylinder along its axis parallel to its main axis and then I unfold the sheet like this, then this is called as the development of lateral surface of the cylinder. If this is a solid cylinder, or if the cylinder is having upper face as well as lower face, then both the faces would be circular. So total development of the cylinder would be one rectangle and two circle, and this is just the development of lateral surface of the cylinder. Now we know what should be the length of this paper. The length of this paper will be equal to the periphery of the circle, that is equal to pi into diameter of the circle. Cut this section from one side as we did, unfold the sheet completely. The shape of unfolded sheet is called the development of surface of that object, as we did in case of cylinder. The similar exercise could be done for prism, pyramid, or cone. The solid may be frustum if it is cut at certain section. If the pyramid or cone is cut at certain angle along its axis, then it is called as the frustum of the solid. Now why we discuss this chapter? You might have seen this boiler shell. You might have familiar with the chimney, household application, pressure vessel which is used to store the fluid at higher pressure. It may be liquid, it may be gas. Shovels, user friendly object. These all are objects which are very difficult to manufacture by any conventional manufacturing processes. So to fabricate these products, the development technique is used. There are numerous of examples of development of solids. Say this is the body of a car, that is also the development of surface, and outside frame of aeroplane, that is also one example of development of the solid. So these are the basic applications of this chapter. Then development of lateral surface of prism. We discuss about prism. We know prism means two regular polygons joined by straight line or edges like this. The regular polygon may be pentagon, it may be hexagon, triangle, heptagon, octagon, whatever. And both the faces are joined with a straight line. It is specified by side length A and height h. And number of and if we develop the outer surface of this prism, it would appear like this. If it is a pentagonal prism, 5 rectangles would be there. The height of this rectangle will be equal to the height of this prism, and total width of each rectangle will be equal to side length A. So total width of the rectangle would be equal to A plus A plus A plus A plus A, 5 times A, as it is the case of pentagonal prism. Similarly, if it is the case of hexagonal prism, 6 times A would be the total width of this rectangle. And if the prism is cut at certain angle at any place, then in that case appropriate change will be there in the developed surface. That we will discuss in few coming steps. Now second is the development of lateral surface of cylinder, as we discussed over here. The development of cylinder would be a rectangle. As we know, the specification of cylinder is diameter d, height h. It is specified by these two parameters. And development would be the rectangle with width is equal to periphery of the cylinder, that is pi into d. Now in this cylinder we think about lateral surface development. So we do not worry about the upper face, which is circular, as well as lower face, which is also circular. Just we draw the outer area or outer periphery of the surface. That is the development of cylindrical face. Similarly, these are the two parameters, h is height, d is the diameter. Development of lateral surface of pyramid. As we know, pyramid means one regular polygon and all endpoints or edges are joined to an apex point. Here 4 corners are there, say A, B, C, D, whatever name you can give, and all these points, corners, are joined with a straight line or slant edges to an apex point. This point is called apex point of the pyramid. Here it is a square pyramid, so 4 triangles would be there along its outer surface. So if we developed the outer surface of this pyramid, it would appear like this. Here S is the side length of the base or square, L is the length of slant edge. Here we should take care about the true length. Here L would be equal to the true length of the edge. Here we should not take the length of front view or top view. It should be taken care of this thing. L is the true length of the slant edge. Take that distance as a radius, draw an arc, and on this arc cut the points at a distance of S on this arc. Cut it 4 times and complete 4 triangles which are joined at one point. This at this point. So 1, 2, 3 and 4. 4 triangles are there which are joined by straight line, and this is the development of lateral surface of pyramid. It's very simple. L is the slant edge and S is the base or edge of the base. Then next is the fourth solid, that is lateral surface of cone. We discussed about cylinder, about prism, about pyramid. Now fourth solid, that is cone. We discussed many examples in the previous lecture about cone as well. Just in development of outer surface of cone, it appears like this, right? Cone is specified by base diameter d as well as height h. and length of slant edge L. What is difference between height of cone as well as length of slant edge? Length of slant edge is the true length of the slant edge, whereas height is not the length of slant edge. It would be lesser than length of its edge. So here we should take care about this thing, that we should take true length only, that is L, and draw an arc. We know about this calculation, where R is the base circle radius, that is radius of the cone. L is the slant height or length of the slant edge, it is called as slant height. So in development, we know the development appears as a sector of circle like this. The development of the cone, if you cut this cone along its axis or along any surface and open it, it would appear like this, a sector of circle. Now how to find out how to draw this arc? As we know, the length of this arc, that is equal to 2 pi into r, that is the periphery of the circle, that is pi into d or 2 pi into r, right? So arc length is equal to 2 pi into r, and we know arc length is equal to angle into radius. Here in this arc, radius is L, that is length of the slant edge, and angle is theta, this angle is theta. So L into theta is equal to 2 pi into r. It's just pure basic mathematics which we learned at primary level as well. So theta is equal to, if we put theta over here, that is equal to 2 pi upon r, 2 pi r upon L. So theta is equal to 2 pi r upon L. We know 2 pi is the radian, convert it into degree, so it becomes 360 degree. So angle theta is equal to 360 degree into radius of this cone upon length of slant edge. And after finding this angle theta, draw this angle and cut this arc. And this is the development of a lateral surface of the cone. So I hope the calculation of this angle theta would be clear to you. Then development of lateral surface of tetrahedron. We know tetra means 4. Tetrahedron means 4 equilateral triangles are joined like this. All faces are triangle and 4 faces are there. If we develop its lateral surface, it would appear like this: one triangle, second, third and fourth. 4 triangle would appear. All triangles are equal in length. That is the development of tetrahedron periphery or outer surface. The next case, that is basic concept of last solid, that is lateral surface of cube. As we know, cube is having 6 faces, that is square, 6 squares are there. This is a cube. If we develop all these 6 faces, it would appear like this. In case of cube, if we tell lateral surface, it includes all 6 faces, because in upper and lower both are similar. All 6 squares are of alike dimension, so this is the development of lateral surface of cube. Now this what we discussed right now was just a very basic concepts. Now which are the practical problems used in industry, faced in industry, this we will discuss. Some combination of some solids, some techniques that we are going to discuss right now. The first problem. In the first problem, it is of cylinder. The dimension is given, the data is given like this: a cylinder diameter 50 mm and 70 mm height is standing on HP on its circular base. Here you can see a cylinder of diameter 50 mm is given and height 70 mm is given. It is standing on HP on its circular base. It is cut by a cutting plane which is parallel to VP and perpendicular to HP. The cutting plane is 12.5 mm away from the axis. Draw development of lateral surface of the solid. How to draw development of lateral surface? This is given data. A cylinder is given. Diameter of the cylinder is 50 mm. height is 70 mm, standing on HP on its circular base. It is cut by a section plane parallel to VP, perpendicular to HP. So first draw a cylinder of given dimension, draw XY line that represents intersection of horizontal plane and vertical plane. Draw a circle of given dimension, that is diameter 50 mm. Draw projections from its top view. This is a front view of given cylinder. Height is given, that is 70 mm. This was just simple. Now we have drawn the first line of this problem. A cylinder diameter 50 mm, 70 mm height is standing on HP on its circular base. This we have drawn. Now next, it is cut by a section plane parallel to VP and perpendicular to HP. Now if any plane is parallel to VP and perpendicular to HP, that would appear as a straight line in a top view. So we think about the top view, that is circle over here. This circle is top view, and here this plane which is parallel to VP is cutting plane is 12.5 mm away from the axis. So this is the axis of this solid, and from this axis this is the axis. From this axis we have to draw the cutting plane at a distance of 12.5 mm like this. These are the sections or imaginary generators over the solid. This is a cutting plane. This one is the cutting plane which is 12.5 mm away from the axis, and here this red colored line is the cut portion or cut section. We are cutting this solid over here. After cutting this, what should appear in the development, that we have to draw. Now cut it along